So the first thing I'm going to do with this irrational equation is I am going to just bring one of the surd terms over to the right hand side and before I square both sides. So I'm going to leave the root 5x plus 1 here on the left hand side, and then if I subtract root x plus 1 from both sides, I get equals 6 minus root x plus 1. Now I'm going to square both sides. Now squaring both sides is fine for the left hand side, but for the right hand side we just have to make sure to put that in a bracket before we square it. So squaring the left hand side, if we square a square root, we just get the terms underneath that square root, so that's 5x plus 1. And then squaring out the bracket on the right hand side, we square the first, 6 squared is 36. We square the last, minus root x plus 1 squared is plus x plus 1. And then we find the product of the two and we double that. So the product is minus 6 root x plus 1 and then times that by 2 to give us minus 12 root x plus 1. I'm going to collect the surd term on the left, so I'm going to add a 12 root x plus 1 to both sides, and then I'm going to collect all the other terms on the right hand side. So I have 36 plus x plus 1, and then I'm going to subtract a 5x from both sides, and I'm going to subtract a 1 from both sides. This gives me that 12 root x plus 1 is equal to x minus 5x is minus 4x, and then 36 plus 1 minus 1 is just 36. I'm going to square both sides again. I still have a surd in the equation, and so this sometimes occurs in a question where we have two surds, which we do in this question. So I'm going to square both sides again to try and eliminate the surd term on the left hand side. So if I square 12, I get 144, and then if I square root x plus 1, that's just x plus 1. Equals, squaring out this bracket, I square the first, minus 4x all to be squared is 16x squared, and 36 all to be squared is plus 1296, and then twice the product, well, minus 4x by 36 is minus 144x times 2 is minus 288x. I'm going to multiply the left hand side, so I get 144x plus 144 equals 16x squared minus 288x plus 1296. I'm going to form a quadratic by bringing all of the terms to one side. So I have 16x squared minus 288x minus 144x is minus 432x. And then 1296 minus 144 is plus 1152. And this is equal to 0. All the terms are divisible by 16, so I'm going to divide across by 16 to make the factorization easier. We could always use the minus b formula, but where possible and we can factorize, it's a good idea to go ahead and do that. So dividing all the terms by 16, I get 16x squared divided by 16 is x squared, minus 432x divided by 16 is minus 27x, and then 1152 divided by 16 is 72. I'm going to open up two sets of brackets, and I get an x and an x as the first terms in both brackets, and then two numbers that multiply to give 72 and are 24 and 3, and I can see the product of the inner terms is 24x and the product of the outer terms is 3x, and if I subtract 24 and 3x, the sum of those is minus 27x, which is what we need. So we need two minuses in the brackets. I'm going to let each bracket equal 0, so x minus 24 is equal to 0, in which case x is equal to 24, and then x minus 3 is equal to 0, in which case x is equal to 3. So these are the two solutions we've got, but in an irrational equation we have to test the solution. So testing 24 and 3 one at a time by subbing them back into the original equation, we have the root of 5 times 24 plus 1 plus the root of 24 plus 1, and we're going to see if this is equal to 6. So this is the root of 5 times 24 is 120 plus 1 is 121 plus the root of 25. We're going to see if this is equal to 6. The root of 121 is 11, the root of 25 is 5, and 11 plus 5 is not equal to 6. And so x equal to 24 is not a valid solution. So we go ahead and test x equals 3. So subbing it into the same original equation, we have the square root of 5 times 3 plus 1 plus the square root of 3 plus 1. And we're going to see if this is equal to 6. This is the root of 5 times 3 is 15 plus 1 is 16 plus the root of 3 plus 1 is the root of 4. And again, we're going to see if this is equal to 6. The root of 16 is 4, the root of 4 is 2, and 4 plus 2 is 6, which means that x equals 3 is the only valid solution to this irrational equation.